Let's consider the proton transfers that could occur in the body with amphetamine. Well, once it hits stomach acid, or HCl, what could act as a base? Anytime you're looking for a base, look for either a pi bond or a lone pair of electrons. In a later chapter, we're going to talk about why pi bonds of an aromatic system are pretty stable and not very reactive. But for this point in time, you don't need to know that yet. The most basic electrons are on nitrogen. So a lone pair on nitrogen could attack hydrogen of HCl, displacing chloride. If we redraw that, we've now done a protonation on nitrogen. It has a positive charge now. And chlorine is a counterion, so we've generated a salt. Once this compound reaches the intestines, there's some base, so something else with a lone pair of electrons, that could come around and retake this hydrogen back and give nitrogen back its lone pair of electrons, so it's neutral again. B is not boron. This is just any general base. They didn't tell us what base is used within the intestines, but B stands for base, not boron. So that gets us back to the amphetamine we started with. What's left over? Well, if your base is neutral to start with, it'll have a positive charge and be a salt with chlorine, and it just made a new base hydrogen bond. Which of these two species is more able to pass through a cell barrier? Well, it's pretty difficult to get a salt or a charged species past a cell barrier or a cell membrane because of the very hydrophobic centers within the cell membrane. So hydrophobic meaning afraid of water or afraid of charge, essentially. So this is probably going to be able to pass through a little bit easier. So that's why it could occur after the intestines.